Hi, in this lecture we'll be coping with integrals that involve square roots of sums or differences of squares such as these, just to make them easier and convert them to more manageable forms. And now let's dive in and see how it works. So this one is actually related to sine. So all these three are related to trigonometric functions, or we could say identities in general. For example, this one is related to 1 minus sine squared theta, which is cosine squared theta. Okay, this is of the same form. 1 minus x squared, 1 minus sine squared, or a squared minus sine x squared is a squared minus a squared sine squared. Something like this. Okay, now we're gonna set x to be equal to a sine theta. Therefore, the square root here in this case is going to equal a squared minus a squared sine squared and theta. So we're going to take a squared as common factor under the square root. We're going to have a squared 1 minus sine squared theta. And we know that 1 minus sine squared theta is cosine squared theta. Therefore, we're going to have a squared cosine squared theta. And a is a positive number that can easily come out of the square root. And then we're going to have cosine squared theta, where cosine squared theta under the square root is absolute value of cosine theta. This is the absolute value of cosine theta. Therefore, if we have the domain from minus pi over 2, which is this one, to pi over 2, which is this here, this point. Then in this region, cosine theta is going to be positive. So if we have cosine in this region, then it's going to be positive, and since it is positive, we can take it out of the absolute value. So we're going to have a cosine theta. And now for the second one, here we're going to say x equals a tan theta. Therefore, this one is going to equal square root of a squared plus a squared tan squared theta. And we're going to have a squared 1 plus tan squared theta. 1 plus tan squared theta is secant squared theta. Now we're going to have a squared secant squared theta. And secant is the reciprocal of cosine. Therefore, from minus pi over 2 to pi over 2 is again positive. Of course, here in this case, because it's the reciprocal of cosine, pi minus pi over 2 and pi over 2 are not included. Therefore, we're going to have a secant theta. And the third one, we're going to say x equals a secant theta. And now the square root is going to equal a squared secant squared theta minus a squared. We're going to take a squared as common factor under the square root. And then we're going to have secant squared theta minus 1. Therefore, this one is going to equal a squared times secant squared minus 1. Secant squared minus 1 is tan squared. Therefore, we're going to have a squared tan squared theta. And in this case, if tan theta is positive, which is in the first quadrant and in the third quadrant, then we're going to have a tan theta. Okay? And now we're going to solve one problem related to this one, for example, the first one, this one, the first one. Let's say we have number 1, I standing for integral equals x dx, and now let's say we have 9 minus x squared. So in this case, we're going to have x being equal to square root of 9, which is 3 sine theta. Therefore, dx is going to equal 3 cosine theta d theta. And now we're going to have I equals x, which is 3 sine theta times 3 cosine theta, and here's d theta, divided by 9 minus 9 sine squared theta. And this one is going to equal 9 sine theta cosine theta, and here's d theta, and this one is going to equal 9 1 minus sine squared theta. So 1 minus sine squared theta is cosine squared theta. We're having 9 sine theta, cosine theta, and here's d theta, and then we're going to have 9 cosine squared theta. That yields 9 sine theta, cosine theta, 3 cosine theta in this case, and we're having d theta here. Then we're going to cancel cosine with cosine. Okay? So we're going to get 9 by 3 is 3 sine theta, and cosine by cosine is just 1. Here's the theta, and we're going to get minus 3 cosine theta plus c. And now we had x being equal to 3 sine theta, which means sine theta equals x divided by 3. And now let's plot a right angle triangle. This is the right angle triangle with theta being here. This is theta. Therefore, x is the opposite and 3 must be hypotenuse. Therefore, the adjacent is going to be 3 squared minus x squared, which is 9 minus x squared under the square root. All right? So we're going to have minus 3, and cosine is adjacent divided by hypotenuse. This is the hypotenuse and this is the adjacent. 9 minus, this is x squared, minus x squared plus c. Therefore, we're going to have minus I being equal to minus the square root of 9 minus x squared, and here is plus c. And that's it.